Well, thanks very much, Pete, and good morning, everybody. It's fantastic to see so many of you here with us again today. It's going to be a fantastic day. Now, Pete has already done a great job of introducing our theme for the day, integrating everything, everywhere. Now, to me, that feels like a bold ambition, right? That feels like a difficult thing to do. How do we make sense of a world with so many different facets and ecosystems, so many different measurements and different paradigms? Well, we're not the first people to ponder these things, right? Back in the ancient world, Plato and Aristotle wrestled with the profound interconnectedness of our planet. Meanwhile, Pythagoreans argued that all is number. It's mathematical harmony that connects nature. Much more recently, in the 19th century, German philosopher Hegel, he observed that our world is connected through culture, commerce, and conflict. Don't we feel that today? In the same time frame, Eunice Newton-Foote was using science to understand connectivity. She was the first person to discover that CO2 and moisture trapped heat, and she predicted that an atmosphere filled with this gas would lead to high temperatures. A little later, Albert Einstein famously went microscopic to understand connectivity. He described quantum entanglement, the relationships between subatomic particles, as spooky action at a distance. I like that. Spooky. You see, since the dawn of time, we have been seeking to understand our world and its profound interconnectedness. And over generations, society has made great leaps in philosophy, science, and technology to progress these things. So today we shouldn't lose sight of the fact that we stand in light of all of these things on the shoulders of giants with the responsibility, and the privilege of taking the next steps forward. So how do we do that? Well, here in the geospatial community, as Pete was talking about, we recognize that geography is a universal connector. We can use geography to understand our world, to understand the systems of our world and the interconnectedness of those systems. And we can use it to model different behaviors and to make decisions. And here at Esri, what we do is we build technology that helps you to do that. We call it ArcGIS. It's a platform of capabilities that you and your organizations can use, in fact, you do use, to build and operate the systems of our planet. And these systems, you can see some of them appearing on the screen here. They don't exist in isolation, right? But they're connected through geography. Actually, whether we realize that or not, they are inherently connected through geography, through location, through the spatial relationships that they have in common. And these systems that we build with ArcGIS, they allow users across our organizations to leverage geography in decision-making across a whole variety of different roles, of different functions, and different domains. And this is no accident. We have actively designed ArcGIS to work like this, to be applicable to a variety of different users working in different roles and different workflows. Now, these systems we build with ArcGIS are well-architected. Well, what does that mean? Well, as you build these systems in your organization, you want to do that with consistency, right? You want to do it with patterns and best practices. And so we have spent time building the ArcGIS Architecture Center, and in there you'll find the well-architected framework. It's a set of information, including these system pillars that are on the screen here, that provides you context to design systems according to your organization's standards in areas like security, like performance, like observability. And in fact, we've gone one step further than that, but we've actually created a set of system patterns, blueprints of the most commonly designed and architected types of system, and they're there available for you to go and find, whether that's enterprise mapping systems, real-time data systems, big data analytics systems, and lots of others. Now, as I mentioned, these systems that we build don't exist in isolation, but they're connected together. In fact, that's a theme that we're seeing increasingly as organizations not only build these systems, but bridge them together, using connected or real-time information flows to bring intelligence and context for better decision-making and building connected or living digital twins. And to support this work, we at Esri have focused a huge amount of effort on integrating ArcGIS with other systems. And this work is vast. Some of it is about integrating with other enterprise systems like SAP, like Autodesk, Salesforce. Some of it is about strategic partnerships with organizations like Microsoft, who we've worked with to spatially enable the Microsoft ecosystem from the inside out, to provide Microsoft users with access to ArcGIS natively within their tool sets. And then beyond that, we recognize that increasingly you and your organizations are adopting big data strategies and working with big data architectures like Snowflake and Databricks, so it's essential that ArcGIS integrates with these technologies as well. So this morning, what I'd really like to do is jump straight in and invite Sacha here to shine a light on some of this. What does it really look like as we start our journey of integrating everything everywhere? Sacha.
Thank you, Mark. So how can we integrate our work across systems and teams with ArcGIS? Well, to walk us through this, I'm going to explore an insurance scenario. As a global community, but also as a nation, there are new challenges and risks emerging all the time, whether that be environmental, health, financial. I mean, these are just some of the headlines we've seen in recent months on screen. Now, more than ever, organizations need to be geospatially enabled to better understand these challenges and their associated risks. But having that information scattered across teams, across systems and document libraries can make it difficult to draw everything together and respond effectively. Now, most of us in this room work on a project-by-project basis. And let's be honest, a lot of the time that can look a bit like this. We've got data stored in different data platforms, documents of all kinds in all different places. We may use one system for one thing and another system somewhere else. But what I think we're all striving for is something a bit more like this. Organized, structured projects with defined outputs. Now, insurance companies, like many organizations, work with lots of different systems, and they handle large volumes of data. So what I want to show you today is how we can make the most of ArcGIS integrations with Microsoft and with cloud data platforms to take steps towards this. Specifically, today, we will look at integrations through ArcGIS for SharePoint and Databricks to understand how we can turn data into outputs that our users can interact with through maps and through applications. Now, integration in this way is applicable across a range of industries, so I'm confident you can all find something today that will relate to you and your business workflows. With that, let's jump into ArcGIS for SharePoint. Now, what I want to achieve with SharePoint is to take the documents that users already store in Microsoft 365 and enrich them with location intelligence, directly where your teams are working day to day. Now, if you work in SharePoint or in those project environments, you're probably familiar with a site that looks something like this. Within this site is a document library where teams from across my organization host tons of different information. For example, if I head into this Bermondsey portfolio file here, we can see documents relating to property plans, asset valuations, images, and so on. What I want to show you today is how we can bring geographic context to users of this site by associating those documents with a specific asset and location. As an editor of this site, I have embedded a web map you can see now, which shows my company's Bermondsey property portfolio in blue. Now, as an editor, I can then add that geospatial context to those documents we saw earlier by geotagging them. Now, I'm interested in this property here, which some of you may recognize to be the Shard at London Bridge Station. It's high-value, critical infrastructure that needs to be reassessed to ensure that coverage reflects current replacement costs and risks associated with aging, with operational changes, or with future changes like climate change. Once connected in the web map, I can then sort through that document library I showed you earlier to find the relevant PDFs, images, or plans that I want to attach. I can then connect those documents directly to my asset of choice by dragging them and dropping them. Once that connection has then been successful, I will be able to republish this web page, making that web map and all those new associated documents available to wider teams across my business, who can access all that information in one place. But the connection doesn't stop there. These geotagged documents will carry through into ArcGIS too, and I'll promise to show you that a bit later on. But first, let's take a look at how we can bring in large volumes of external data to help us understand the bigger picture. We've had a look at a single asset, the shard, but in reality, insurance companies manage thousands of commercial assets and store large volumes of data in external platforms to be used by their teams. The challenge is that this information is vast. Here I have what is a sample of 10,000 rows of asset information stored in cloud platform Databricks. It constantly updates, it's stored in complex tables, and it serves as a hub for data analysts, data engineers, and data scientists across my organization. So how can I integrate this with ArcGIS? Well, if you've used Model Builder before, you may be familiar with a layout that looks something like this. This is ArcGIS data pipelines, and it will allow us to connect to our cloud data platform of choice, decide which subset of data we want to work with, and then create interactive outputs that our users can engage with. So let's step through this one together. First, I'm connecting to that Databricks environment. I'm then filtering that data by selected attributes. So you can see from my query here that I'm only interested in multi-story residential properties built pre-1950, which represent higher risk and therefore need more urgent reassessment from my organization. I'm then turning that data into points on a map that I can preview. And finally, creating that feature layer output stored in my ArcGIS online content, which will allow users to interact with this output through maps and through applications. What's important is that you don't need to be a developer to integrate cloud data with ArcGIS, and I'm certainly not one, so hopefully that instills some confidence in you. Let's head into the map viewer. Now that we've done that additional work in Databricks, we can turn to ArcGIS to help us build up a clearer picture of our project. Zooming in, we can see that same web map we saw earlier in SharePoint. So if I visit the shard once more, we can see the output of that SharePoint integration, where I can see those documents that I had geotagged earlier. Here's London on a good day. We can also then lean on the ArcGIS Living Atlas of the World for some geospatial insight into our area. For example, I may want to understand access to my sites, and therefore I could bring in the live traffic feed to understand where my access points are. Or maybe I'm interested in surrounding buildings, in which case I can make the most of the local buildings layer contributed by the OS. Or maybe I'm more interested in my surrounding population, in which case I'm in luck. There's a wealth of demographic data available in the Living Atlas too. I've also brought in some open flood risk data from the Environment Agency to help me understand collective flood risk to my assets. And I've brought in some background imagery for context too. This allows me to quickly produce dynamic and enriched views of this exposure, meeting my teams where they're working, whether that's in ArcGIS or wherever that is. Finally, I want to create an application that users outside of my asset reassessment team can use to ask questions and receive answers. Here, I could create a dashboard or an experience builder app, for example. But what I want to show you is how we can make the most of an out-of-the-box app template integrated with an AI agent to achieve this. So, using the Instant Apps Data Explorer template in beta, I've done just that. We're familiar with that web map on the right, but now users from across my organization can ask questions in plain language to receive instant insight into this data. Here I have 2 prompts ready to go. As a first example, engineering teams from across my organization may ask questions around site accessibility to ensure there's wide enough access for large vehicles or for machinery during reconstruction. So, which insured assets have construction access? Behind the scenes, the AI agent will execute work on my behalf to sort through the data it's been given and provide an answer to my query. You can see here that I still have input along the way, acting as the human in the loop to help guide this process. The AI agent will then decide which type of geoprocessing needs to be carried out, obtain my consent for credit consumption, run that analysis, and then filter the web map to show me a new feature layer output stored directly in my ArcGIS online content, which will show me which of my sites have access from nearby A roads. This allows me to delegate my tasks to the AI agent, which will then carry out that work within the bounds of my authority, saving me time and resources. As another example, let's look at flood risk to my assets as the focus for our prompt. So, which of my insured assets are within flood risk zones? The same process follows again. The AI agent will analyze the data, request my input to help it weigh up the best tool for the job, alert me of any credit consumption as analysis is carried out in the web, and then filter my web map to show me that new feature layer output stored in my content where my assets are in flood risk zones. As you can see, I don't need to have GIS experience to use this application. And importantly, I don't need the time or support of those in my organization who do. This frees up the time of your GIS teams across the business, while helping to build that general familiarity with geospatial intelligence, connecting teams and systems together in one unified user experience. With that, thank you, and back to you, Mark.
Sacha, thanks very much. Fantastic job. And did you notice Sacha there? She finished up showing us Data Explorer with an AI agent that she was delegating work to go off and do on her behalf. Now, I'm aware this is going to be new for many of us, so I want to talk about some of that. But first, let me put it in context with the wider story around how we are integrating AI with ArcGIS here at Esri, because we're doing this in 3 ways. The first one is what we call GeoAI. This is about using AI techniques to solve geospatial problems. And to do that, we draw on the multiple subfields of AI. Areas like machine learning, computer vision, pattern recognition, to really supercharge our ability to analyze information and predict patterns. You see object detection, feature extraction, change detection. These are all really geospatial questions. So the way that we answer those is by using techniques that are grounded in AI. That's what GeoAI is. These approaches are very mature. They've been within ArcGIS for a long time. They're tried and tested. They're available for you to use and to extend. The second area is AI assistance, which is really about simplifying access to GIS and expanding productivity. Now, the approach that we've taken here is to build a set of context-aware assistants that are specifically designed to support different users in different roles across workflows. So what do I mean by that? Well, let's imagine that I'm a map creator. What would be really helpful for me would be to have context-aware search and discovery powered by AI that would help me to find the data sets that I'm really looking for more accurately. But then imagine that I'm a power user deploying apps across my organization. Well, what might be helpful for me would be to have a natural language conversation with an AI to build that app, like you can do today in Survey 123. Or what happens if I'm a developer? Well, I would like context-aware code generation, specifically within the environment or the IDE that I'm working in. That would really help me. So that's what I mean by our approach is to build context-specific, role-specific, workflow-driven assistants that support us and come alongside us and help to enhance our productivity. So that's the second area, AI assistance. And then we've got this third area, right, AI agents. What does it mean that ArcGIS is becoming agentic? Well, agents go one step further than assistants. Rather than just asking an agent a simple question, I want you to just imagine an agent is like a smart digital helper that I can send off into an environment according to a set of rules that I define. And it can go away and make decisions and execute tasks and evaluate outcomes, decide what to do next, execute that, and so on, all whilst maintaining a dialogue with me, because I'm still in control. It's acting as my agent on my behalf. It's delegated authority. So ArcGIS becoming agentic is really about taking those behaviors that I've just described and deploying them in two different ways. The first way is what we call geocentric. It's about doing those things inside the ArcGIS system. Sacha has just showed us this. She had an AI agent go away and tell her about access to sites for construction or flood risk of different assets. And in each case, the agent understood the context of the question. It went away and found the data sets that it was looking for. It identified which analysis tools were the most appropriate to run. It brought all of these things together, executed the analysis, and presented Sacha with the results, all the while keeping her briefed and in control, checking in that it was doing things that she was comfortable with. That's geocentric. The second area is about geo-enabling other enterprise systems to be able to tap into ArcGIS and ask those questions. Because any system, any external system, might have spatial questions and need access to a powerful spatial reasoning engine to answer them. Well, guess what? You have one of those. It's called ArcGIS, right? So this is about us at Esri enabling you to integrate ArcGIS with any of your other business systems through AI agents. Now, in order to do that, ArcGIS needs to be able to speak a common language with those other agentic systems as well. And there are a number of emerging standards in this area. One of them is called Model Context Protocol. It's quite common at the moment, MCP. So the work that we're doing at Esri is to integrate MCP support into ArcGIS to allow you to then use ArcGIS in the ways that I have just described. Now, this is work that we are doing right now. So actually, we're going to talk a little bit more about this in the Road Ahead session this afternoon, so do come along to that. Now, these advancements are really powerful and exciting, but they are moving at a pace. And so at Esri, we feel it is really important as we integrate AI with ArcGIS to address trust and ethics. In fact, it's essential, I think, that we give you control, transparency, and choice in this area. And that's why trusted AI is really at the heart of how we are doing this. We've put a huge amount of content into the ArcGIS Trust Center, the principles that we've adopted at Esri as we go about this work, how our tools work, what they're built with, what happens to your data when you use those AI tools, how do you maintain control and governance across all of these different tools that are deployed inside ArcGIS across your organization. All that information and much more is in the Trust Center. So I really encourage you, go and look at it, think about these things, stress test it, find your comfort zone with this stuff. And also, we really invite your feedback on this as well. What else do you want to know about around the inner workings and transparency of AI? Now, I started this morning by talking about ArcGIS as a platform of capabilities. And really in this session so far, we focused on two areas. We've looked at integration, and we've looked at AI. And we've also looked at the overlap, if you like, in the Venn diagram of those two areas, which is really AI agents. But there's so much more that I'm really excited to share with you this morning in the area of the platform capabilities. And so to lead us through this next section, please welcome to the stage Lauren McArtney.
Sweet, thank you very much, Mark. Now, everyone in this room will be using ArcGIS in a slightly different way. But the decisions that we all make, they start in a similar place. And that is with content that we can rely on. Now, this might be your own content, it might be shared to you by somebody else in the community, it could be from the person that is sitting next to you. The Living Atlas is where this content, it all comes together. This is the world's largest collection of geographic information. It is curated and it's maintained, and it's built from contributions from Esri, from our partners, and crucially, from you, from the GIS community. Now, it's not just data or data. It includes maps, you've got apps, you've got live data feeds, you've got pre-trained machine learning models. You've got base maps that come in every flavor. You've got everything from ancient woodlands through to cable agreements. You've got highway boundaries, open roads, air quality, moorlands. Sacha just brought in a few great examples as well, right? She brought in live traffic. She brought in OS buildings, demographics. This is your work. This is what makes up the Living Atlas of the UK. You are the very organisations that have built this library up to over 10,000 items. And you're also the very best people to continue to grow this really incredible resource. Now, while content, it is key for it to be useful at scale, so to move between users and teams and applications, it needs a common language. And that common language is the web map. Now, I do hope that this is familiar to many of you. It's one of the most important concepts that we have in ArcGIS. The web map is how content from the Living Atlas, from your own systems, from external systems, becomes something that every user, every app, and every workflow can then understand. And how our web maps are presented, it really matters, right? Which is where mapping and cartography come in. Now, ArcGIS has been intentionally developed to support really powerful visualization. Symbology, labeling, layouts. These are all the choices that we make to help our maps tell the right story to the right audience. And ArcGIS has a set of tools to help you tell really compelling stories. You've got app templates, you've got instant apps, dashboards. These are all purposefully developed to support you in creating really fantastic stories. Now, when we build geospatial applications, we start by mapping the world as it is, don't we? We map places, objects, where things are. But from this, the focus, it starts to shift. We start to see patterns, relationships, interactions. We move away from just wanting to understand where things are to looking at how they relate, and really importantly, why that actually matters. And that is where spatial analysis comes in. Now, we often talk about ArcGIS as a platform of capabilities. That is literally what I am talking to you about right now. But spatial analysis, well, that's a platform of capabilities in its own right. It's a platform for spatial statistics, it's for, data engineering, data science, it's for big data analytics. Sacha just showed us a great example of that earlier. It's for understanding entity relationships through graph analysis. Mark spoke earlier about AI, and this is an area where AI becomes really deeply embedded through geo-AI, where we take machine learning and we combine that with spatial analysis to detect patterns. Now, another area that is full of comprehensive capability is 3D GIS. And in ArcGIS, 3D is not considered a specialist tool. It is used across the entire system. We use it in analysis, visualization, data management. And that really matters because 3D is what gives us the additional context. It helps us to understand how things relate vertically and how they relate spatially. Now, if 3D gives us that structure, then imagery is what gives us the detail. With imagery and remote sensing, we can see the real world through data that is collected from satellites, drones, aircrafts. And ArcGIS provides a complete system for working with this imagery, from managing large volumes, all different formats, different resolutions, and then turning this imagery into really powerful information products. And then it's just about bringing it all together with reality mapping. Now, this takes the structure of 3D and that really rich detail of imagery and remote sensing, and it fuses them into a single immersive view. LiDAR, imagery, photogrammetry, new techniques like Gaussian splats, which you're going to see shortly. We can create really spatially accurate and really highly detailed models of the real world. This could be from a single site or a single building through to a city, to the entire country. And these reality layers are what become the fabric of digital twins and of immersive experiences.
Lauren, let's just take a pause for a minute. You've just taken us through some really big hitters, right, in the platform capabilities inside ArcGIS. We talked about spatial analysis and how it's almost a platform of capabilities in its own right. We've looked at 3D and its pervasiveness across the whole of the ArcGIS platform, looking at imagery and how they come together for this newer area of building these immersive experiences inside reality mapping, right?
Yeah, and what's great is that we're seeing imagery is that this is just a part of everyday workflows. It's really core to GIS users. It's in everyday kind of tools and tasks.
So I think this is a great time to pause for a moment and invite Miles here. Miles is our resident expert in imagery, so it's great to have him with us today. So let's invite Miles to take us through what some of this really looks like in reality. Miles.
Thanks, Mark. Good morning, everyone. Let's start with a trivia question. What does Waddesdon Manor, Cragside Manor, and Bodiam Castle all have in common? Any guesses? Well, if you're thinking Bridgeton, unfortunately, that's not the right answer. Actually, it's National Trust. And to give you a sense of scale, they were founded over 130 years ago. And in that time, they've approximately built 5.3 million members. They also spent £61 million this year alone into caring for houses, gardens, and collections. And they also look after 800 miles of coastline. And if that's not enough, they also look after Newton's apple tree. But across similar organizations, estates have faced unprecedented environmental and operational pressures. There's been major tree loss with multi-year restoration across the northeast. But when nature's not throwing a curveball, inflation and tax rises strain operational budgets. But let's jump specifically back to the National Trust, and they face some positive challenges, like a surge in 18 to 25-year-olds, growing membership by 39%. So how do they cater for all this new footfall? And when these events outpace your ability to inspect and monitor, organizations lose time, money, safety, and situational awareness. A web environment that can be accessed anywhere, anytime, and integrates everything can deliver real-time situational awareness, even when fieldwork is in areas that have no Wi-Fi or mobile signal. Offline solutions are integrated for a resilient system of record. But how do we get here? How do we get to this intelligence? The National Trust have separate teams that have all these capabilities that I'm going to show today. But I want to reimagine what one combined connected source of truth might look like within ArcGIS. And what we're looking at now is a connected web environment pulling team capabilities together. Now I'm going to focus on the West Yorkshire properties here, and specifically Nostell Priory. And here are 3 applications providing different operational value. Here, a LiDAR dataset provides the backdrop to Nostell Estate, giving us a 3D representation of what is there. Roads, rivers, ancient woodlands, and other datasets can be added from the Living Atlas. If this isn't enough, a true author mosaic can also be added, providing a different viewpoint whilst complementing the LiDAR. Here we can see how it integrates with the other data layers. But I want to jump to an example, and we're going to pick out the ancient woodlands here. And normally, if you wanted to measure the heights of trees, a surveyor would have to go out into the woods and somehow try and measure the height of a tree. But here, we can do it from the LiDAR in less than 20 seconds. I mean, look how easy that is. And I want to jump to one final example here and look at the elevation profile analysis. Here, we can see the roads and the rivers intersect quite closely. And will the river provide a flooding risk here? So what we can do is draw an elevation section here. And here we can see the dip in the elevation where the riverbed is and the raise where the road is. So in theory, it should be safe. But we can also see the floodplains. And it looks like the flooding's there. And we can confirm this by turning the true author mosaic on. The second application here provides a remote inspection capability. Here, we have a beautiful mesh created from one drone flight. Oriented imagery, point cloud, and true author mosaic and Gaussian splats can also be created from this. This is how it was made. Each blue dot shows where the drone was hovering when it took one photo. These images were then processed through our reality engine. The detail is stunning. It really does provide a digital copy of the real world. But you know, photogrammetry is not always perfect. So here we can see the gates and the fence haven't quite come out perfectly. Here I'm just zooming in to show you where the poles haven't rendered. But this is where Gaussian splats step up and provide another level of realism that can solve some of the trickier structures that need to be recreated. I'm just going to zoom in and show you the high fidelity on the detail here. Well, I'm now going to move on to one of my favorite examples in this Gaussian splat. Here we can see the glass has rendered perfectly. This enables objects behind the glass to also be reconstructed. Be careful what you leave on your windowsills. The imagery here provides GeoAI the canvas to automate common routine inspections. I'm going to show you a couple of examples. Here we can detect flaking paint on windowsills. At elevated areas, we can look at blocked drains and also cracked slates. And when this is scaled, this provides real cost and time savings. But let's jump straight back to the window inspection. So here we can see if we zoom in, the paint is flaking off the windowsills. But what if we want to see the original source of truth? So I've clicked on the windowsill and the oriented imagery pops up. So you can see where I've clicked on the red cross. Here we get one point of view, but if the picture's not particularly clear, we can play with the sharpness, the contrast, and the brightness to enhance the image. And if this is not the right viewpoint, we can also go through our image catalog and see which other images intersect with this area. So here I'm going to select another image. And yes, not quite the best viewpoint, but you get the idea. This inspection capability removes the need for scaffolding or rope inspections, and this reduces the risk for multiple teams. But before I move on, given the imagery is so detailed, has anyone counted the number of flies on the window? The third application here provides a field task management level capability. The LiDAR of Nostell Estate provides the background context. All the field tasks are added for one overarching view of the tasks at Nostell. As management, I'm particularly interested in urgent tasks, and I can filter the task by this attribute. But let's zoom into one of these tasks here. So it looks like there's a fallen tree, and we need to assess the safety here. And on the LiDAR, we can see it pretty well, actually. We can also measure the branch and the heights and get a good understanding. But again, we can flick on the True Author mosaic just to understand what it looks like in the real world in RGB. Here we can get a good understanding of what the severity might be. So let's take a step back from this individual task now. This dashboard provides a high-level status for Nostell Estate. It shows that the number of urgent tasks is relatively low at 3, hence the green. However, the overall number of tasks is 8, and they're starting to back up. This dashboard provides me, as the manager, the information that Nostell needs more resources to help clear these backlog field tasks. The dashboard also provides me with the information of how best to divert the resources at a high level. And what I've shown today is not just a compelling visual demo. It's a practical glimpse of how estate managers, like the National Trust, can understand and protect places at scale. A shared 3D digital twin brings complex landscapes and estates into one coherent view, giving teams a common platform to explore change, test decisions, and act with confidence. This is how we move from reacting to change to predicting what comes next. Thank you very much.
Amazing. Well done, Miles. Thank you for that. Now, what you have just seen is reality mapping at its most powerful. But underneath all of that incredible visual impact is something that is just as important, and that is how the data itself is actually managed. Now, geospatial data management is what makes experiences like Miles just showed us even remotely possible. This is where we model real-world systems, so transport networks, utility assets, and then we manage how that data is edited, how it's governed, and how it's integrated over time. And this allows applications and digital twins to stay accurate as the real world changes. Now, one of the areas we're seeing this modeling really come to life is in indoor GIS. And ArcGIS provides a comprehensive data model for indoor environments. But what we're seeing now is I guess, more than indoor mapping. It's about managing and operating complex environments. So airports, hospitals, uni campuses, places where people and assets are constantly in motion. Now, this is a really rapidly growing area. We're seeing huge potential to combine it with AI, and we're doing quite a lot of thinking here, so we'll be talking about that more in the road ahead later today. Now, from managed spaces through to work that's actually happening on the ground. Field operations are about updating and editing data where it is happening. And ArcGIS supports everything from structured data collection through to rapid situational awareness, with applications like Survey 123, which is for form-based workflows. You've got Quick Capture, which is about rapid data collection. And then there's Field Maps, which is for online and offline workflows that are at scale. Now, finally, let's talk about real-time. Today, so much of the data that is being generated from sensors, vehicles, infrastructure, it is live and it's continuous and it is spatial. Now, ArcGIS supports the monitoring and tracking of moving objects and the changing conditions of fixed assets. And this is the sort of data that can be acted on in real time, or it can be stored and analysed later, or it can be combined with some of those spatial analysis capabilities that we spoke about earlier. And it's also an area where integration plays a great part, so taking these live streams of data and turning them into spatial insight.
So Lauren, like you, I always think about real-time as the tracking, the monitoring, alerting of live data, right, and decision-making on that, which obviously absolutely is that. But have you ever thought about using ArcGIS for real time travel? Well, Katie, it's about time, right?
Thank you, Mark. And good morning, everyone. It is my very genuine pleasure to take you all on a journey across space and time. Now, we all know that space and time are linked together. If we go outside and ask someone, how far is it to the nearest coffee shop, we'll probably get an answer in minutes rather than miles. So today, I want to talk about how they're integrated inside ArcGIS. Now, you might not have noticed when you walked in here this morning, but you've actually all sat down inside my time machine. And we're going to go on a little trip together now, all perfectly safe, I promise. First, we're going to travel into the past to see the value of integrating time-enabled data for understanding change and demonstrating impact. And then, assuming we haven't disrupted the timeline too much, we'll return to the present to look at the role that real-time data can play in our operations and how ArcGIS can help with collaboration and scheduling tasks to increase effectiveness. Now, is everybody ready? Hold on tight, and just remember, don't panic. We haven't actually traveled that far back, only to 2008. Outside these walls, the Summer Olympics are about to take place in China. Coldplay have released arguably their best album. And a very ill-advised Indiana Jones sequel is about to hit the cinemas. Oh, and here in London, the low emission zone for vehicles is coming into effect for the very first time. Now, over the next 18 years, this legislation is going to reduce a number of harmful emissions from vehicles. Today, I'm interested in just one of these, called PM2.5. And PM2.5 is tiny particulate matter, less than 2.5 micrometers in diameter. Or to put that in human terms, it's little pieces of dust that are roughly 3% the width of a hair on your head. And they pose a significant risk to human health because they can penetrate deep into the lungs and they can enter the bloodstream. So this is data from the UK air inventory showing background PM2.5 levels from 2008 and 2024. And both of these maps, the dark blue areas have the least amount of PM2.5 pollution, and the light pink areas have the most pollution. And we can see when we zoom out in that 2024 map, there are more of those dark blue areas. Air pollution has reduced over time. But it's quite hard for us to really understand the scale of that reduction because the range of data for these two different years is different. It means that that indicator is having to do a lot of heavy lifting. And by placing these maps side by side, by comparing snapshots, I'm also kind of subconsciously suggesting that there's a linear progression here, that emissions have been steadily decreasing year on year. And that is not strictly true. So to really understand this change, we need a map where time is dynamic as well as space. And the real challenge of making a map like this is the scale of the data. For that 16-year period, there are more than 15 million data points that we need to consider. So I've used some Python code to bring them together into one data set and to also give them an appropriate start and end date based on the year that they've come from. A couple of years ago, this would have been a real challenge for someone like me who is not a developer. But with a friendly co-pilot, it's all become a little bit more straightforward. The next thing that I need to do is just enrich the map with some data from the Living Atlas. That's going to help me focus on my area of interest. And it lets me produce an output that looks a little bit like this. And I am immediately going to share this out to ArcGIS online, because I really love the cartographic options I get there for visualizing data. And it's also helpful if I want to share this as an app down the road. Because time is built into ArcGIS from desktop to cloud, the data drops in pretty seamlessly. So now my choice is the cartographic sort of conventions I'm going to use to represent this pollution data, and I just need to enable my time slider. And now the data is being displayed dynamically, we can start to see some of the hidden narrative within. You'll probably notice, as you watch this change, that in 2011, emissions actually increase. And the reason for this is a spring weather event, a high-pressure event that caused pollution to be pulled into London from Europe, and then a sudden cold winter where people fired up their wood-burning stoves and got in their cars more often, and that caused smog events. So time enabling our map has let us draw out this hidden narrative within the series of data. And for me, this is the real value of integrating time in this dynamic way. We move from these snapshots to a compelling story. Think for a moment how this could be useful in your organization to see your data integrated together in this way. Right. I think we better get back in the time machine before someone tries to convince us that ripped skinny jeans and Ugg boots are an effective fashion combination. Now, brace yourselves. We could be in for a bit of a bumpy landing. In fact, I'm going to ask the time machine to find out the current weather and wind conditions for the moment that we're trying to land back into. I can hook into the Living Atlas live data feeds. So let's take a look. Okay, so it's looking like we're going to have some strong northerly winds to deal with. Everybody ready? Phew. We made it back in one piece. Hopefully nobody at the back was time travel sick. Good. Well, now that we're safely back in 2026, I want to think about how we can integrate these real-time data feeds with some of the future planning capabilities that are also built in to ArcGIS. Imagine for a moment what it would be like if your plan for what should be happening could integrate accurate information about what's actually happening, and if you could see all of that on one screen together. You might end up with an interface a little bit like this one. This is an app that I've imagined for a hospital transport manager. That's someone that needs to understand and control the movement of critical medical supplies and personnel at a glance. Let me break down what we're seeing here on screen. So on the map here, this is the present. These are real-time data feeds coming from ArcGIS Velocity. And I've also added in a familiar real-time feed from the Living Atlas. And these are showing us exactly where our field staff are located at this particular moment and the status of the services they need to interact with, so the traffic that's on the roads and the supply that is in the blood banks. On the other panel here, we have the future. These are tasks that are assigned and tracked using ArcGIS field maps. And I've integrated the future and the present together using an experience builder. Now, you've probably already noticed some familiar names on that calls in progress list. Poor Miles has only just finished presenting, and now I've sent him out delivering equipment. Because he's got a non-urgent delivery to make, he can plan the most energy-efficient route and help his organisation meet its commitments to net zero. For Sacha, who's been assigned an emergency transport, obviously speed is going to be the priority, but it's also really important that we send her to a blood bank that has the supplies that she needs. And that's where these real-time data feeds become critically important. Sacha and us can see at a glance where the stocks are high and where the traffic is flowing freely. Now, another emergency call has arrived on my calls to assign pane, so I'm going to quickly give this to one of the most reliable drivers I know. Lauren, you're up. And there we have it. In slightly less than 10 seconds, we've gone from that call coming in to Lauren knowing what she needs to do and where she needs to go. And while we wait for her to set out on her journey, I'd just like you to reflect for a moment on what the value of this could be in your organisation, this seamless collaboration between staff in the office and staff in the field. Now, you're probably all well aware that products like donated blood can't be used if they're left out of cold storage for too long. And moving a critically ill patient who needs a donation like that is also a high-risk activity. They need to be moved, quickly and to the right place at the right time. So we've set up a geofence around the hospitals that alerts when a delivery driver has left the location and will also alert when they're approaching their location. So this means that rather than having to estimate when to move that high-risk patient, the staff now have an accurate starting bell that they can use instead. Now, don't worry. I'm going to let you make the journey into the future at your own pace. But before you set out into a busy day of conference, I want to just give you a moment to pause and think once more about time, about how you can unlock the hidden stories in your historic data, or seamlessly communicate between office and fieldworks, about how valuable it would be for you to know exactly when materials and personnel were incoming and in what condition they were arriving, and how useful if you could set out a plan for the future and then easily adapt that plan in rapid response to accurate, real-time information. Could it help you save money? Could it help you save lives? Could it even help you save the planet? Thank you very much for traveling with me today, and it's back to you, Lauren.
Amazing. Thank you, Katie. I am also flattered to be your most reliable driver. Thank you. Now, today we have integrated systems, we have integrated reality, and Katie just showed us how to integrate time. But like any robust time machine, what you can do next depends on having the right key. And in ArcGIS, that key is your user type. Now, ArcGIS user types determine what you can do based on how you work. And each of these user types has been specifically designed to support you in your role across desktop, web, mobile. And as we continue to add more and more capabilities into the platform, this is the user type model that will support you with the access you need to keep doing the great work that you're doing.
Well, this brings us to the end of the journey through the ArcGIS platform capabilities. So Lauren, thank you for taking us through that.